Hi everyone, hope you're doing well. Today we're going to look at equations of this form, y equals ax plus b over cx plus d, and basically hopefully you watched the previous videos from exam solutions about reciprocal functions. This is sort of another form of a reciprocal function really, so equations in this form look like the familiar kind of curve like that with these asymptotes. They can often be off center. They can be possibly the other way around, so it might be this way around, and it's not always clear where these asymptotes will be or which way round the curve will be just by looking at it. So we have to do a bit of work to be able to do a sketch of this curve, and that's what I'm going to show you how to do. So let's get rid of this. Let's have a look at this example, 4x plus 1 over 2x minus 6. You can put that on your calculator and have a look at what it looks like. But if we don't have a calculator in the exam, we have to be able to sketch it anyway. So the way to do that are these steps. Find the asymptotes, find the intercepts, and then we can do a sketch. So let's have a look at if we can find the asymptotes for this equation. So why would an asymptote occur? Well, let's look. Imagine you've got one that looks like this. Now this one here is going to occur because at some point you've got a division by 0 and the curve shoots off to infinity, and then there's nothing here. So how could that happen? Well, on this curve here, the only way to get a division by 0 is for the bottom of the fraction to be 0. So if we want to find out where this horizontal asymptote, this vertical asymptote is, we have to look for what values of x will give us that division by 0. So let's do that. So vertical, by the way, I recommend that you take notes along with this video. Don't just watch because you will probably forget. Just note along what we're doing. So vertical asymptote would occur when 2x minus 6 is 0, because that's the only way to get division by 0. In other words, 2x equals 6, or x equals 6 over 2, which is 3. So that means the vertical asymptote must happen when x equals 3 here. So if we do this a bit of a better sketch, we can start to add things onto it. So let's put this here. We now know that there's a vertical asymptote here at x equals 3, like that, because that's the division by 0 bit. Now let's try the horizontal. A little bit more tricky with the horizontal, but basically what we're doing is we're thinking about, let's imagine that it looks like this. How to find this? Well, what this dotted line is it's the y value you get when x is extremely big, because x goes all the way along here and gradually converges down onto this line, this asymptote here. So we need to find out what y is when x is extremely big. So we can do that by just plugging in extremely big numbers for x, but it's a bit inelegant, so there's a nicer way of doing that. So take our equation 4x plus 1 over 2x minus 6. We're trying to think what happens when x gets extremely big. So one thing that's quite nice is you can do it like this. If I get rid of that for a sec, hopefully you'd agree that it's possible to divide the top and the bottom of the fraction by the same thing and still keep the fraction the same. So if we divide the top and bottom of the fraction all by x, like this. Every term, everything, is just getting divided by x. We've got the same fraction, we haven't changed it, because we've done the same thing to the top and the bottom. And then this bit would cancel and that bit would cancel. And we'd be left with 4 plus 1 over x over 2 minus, whoops, I forgot to divide the 6 by x. 2 minus 6 over x. Right, so now remember our question was, what happens when x gets really, really big? What is y? Now if you consider this, think about what happens when x gets really, really big to this part. Well, if you think about 1 divided by a really, really big number, it's a very small number. So when x was infinitely big, you just get an infinitely small number here. So we can kind of rule that out and say it limits towards 0. It sort of becomes insignificant. The same thing here, that also limits to 0. And when x is extremely, extremely big, we're just left with 4 over 2, which is just 2. So we would have y equals 2 left over. So that tells us that when x is extremely, extremely big, y is getting closer and closer to and limiting to 2. So we can then put that on the graph. That's where the second asymptote is going to be, like this, at y equals 2 there. So now we're nearly there. We, 1 second. Yeah, we are nearly ready to sketch this reciprocal function. The problem is we don't yet know if it looks like that, or maybe it's the other way around and looks like that, and it's not actually easy to tell just by looking at the numbers or even the signs. So we have to do a little bit more work to find out. Oh, is that not going to disappear? Oh, weird. Okay, let me see if I can rev this out. Yeah, okay. Cool. So next thing we need to do is to find the intercepts. So let's do that down here. Intercepts. Well, the intercepts just happen when either x or y is 0. So if we just grab that 4x plus 1 over 2x minus 6 again. Grab that again. Right, what happens when x is 0? We get y equals 4 times 0, which is 0, plus 1 over 2 times 0, which is 0, minus 6. In other words, minus a sixth. So when x equals 0, y is minus a sixth. So we can put that on. Go to x is 0, y is minus a sixth. That's here, roughly. Doesn't have to be to scale. It's a pretty awful scale, actually. Maybe I could do a little bit better than that, put it a bit smaller. Minus a sixth there. Let's do it again. This time we'll make y equal to 0. So when y is 0, we'd have 0 equals 4x plus 1 over 2x minus 6. You can bring this whole lot up here and times it by that 0, and then you'd have 0 equals 4x plus 1, take the 1 to the other side, divide by 4, x is minus 1 over 4. So when y is 0, we know that x must be minus 1 over 4. So let's go find y is 0, x is minus a quarter, that's here. Okay, cool. So now we can actually sketch the function finally. We've just got to make sure it goes through those intercepts and down like that, and on the other side it's going to go like that. And that's our sketch of our function. So we did it. The final thing we need to do is find the domain and range. and that's really easy. All we do is we say, so the domain, if you remember, is just what x values are we allowed to put into this function. Well, looking at the graph, you can see any x value can be put in, except x equals 3, because if you do that, you get division by 0. So that's not allowed. So domain is any x value except x is not allowed to be 3. That's your domain. And the range, looking at the function here, is there a maximum y value? No. Is there a minimum y value? No. Is there anything in between that you can't get out of the function? Well, yes, there's one thing you can't get out, and that's y equals 2. So we just go along here and we say y is any real number, but y is not equal to 2. And that's our domain and range. And that's done. Okay, so finally, I just want to just give you the generalization of this. If you look at the way we found the asymptotes, you see we got that y equals 2. Well, how did we get that? Well, we got that by ignoring these two and just doing 4 divided by 2. Now, if it was in the general form, ax plus b over cx plus d, it would have been the a divided by the c, wouldn't it? If you think about it. So the asymptote in general is given as a divided by c. So in general, a over c. And let's look at the vertical asymptote. We got 3, and we got that by rearranging the bottom of the equation. In general, you can see, if you think about it, from this general form, it would have been negative, it would have been from rearranging cx plus d equals 0. And taking d across, dividing by the c, you would have got x equals negative d over c. So in general, that will always work for finding the asymptotes. Let me just see if I've got time to do the intercepts with you. Possibly if we go quick. I'm a bit worried because YouTube doesn't let me upload the video if it's longer than 15 minutes. But the intercept came from the 1 and the 6, didn't it? So here, well, the 1 and the 6 would be the b and the d in the general form, so b over d will give you your intercept every time. And similarly, that was this intercept here, x is minus a quarter, came from the b and the a, didn't it? So it would be the negative b over a. And there's my timer, so I've got to leave you guys. So hopefully that made sense, and watch out for the next video. Thanks, bye.